Today we're going to be talking about arithmetic sequences. Here are a couple of simple bulletin points about arithmetic sequences that we're going to go over, and then later we're going to solve some problems to really show you how arithmetic sequences work. So the first bulletin point of arithmetic sequences is that the common difference is always added or subtracted, unlike in a geometric sequence where the common difference is always multiplied or divided by. The explicit formula for an arithmetic sequence is A1, which is the first term. So if our sequence went 1, 2, 3, 4, the first term would be 1. So that's where you would plug that in. And then N stands for number, or what you're trying to solve for, because it's a formula. So you can just plug in any number. So if I try to find the third number, I'll just plug in 3 there and then solve it all out. D is the common difference, or what's different between each one of these points in the sequence. So this would be +1, +1, +1. So the common difference in this sample would be 1. Now the recursive formula for arithmetic sequences isn't really used for solving numbers, because you would have to know the number before that number to get the answer. So here's an example of one. Say our sequence went 10, 19, 28, etc., etc. This would be the recursive formula for it, because you can see that the first term is 10, and then each term before that you add 9. So just keep going on and on and on. So the example is if AN equals 27, A1 equals -12, and D equals 3, find N. So the first step of solving this type of problem is always plugging in the known information. So we know our explicit formula is AN equals A1 plus N minus 1 times D. So we're going to put in everything we know. 27 equals -12 plus N minus 1, we don't know what N is, times D. So the first step of it is to add 12, so we can simplify this side of the equation first. So we end up getting 39 equals N minus 1 times 3. Now we divide both sides by 3, so we end up getting 13 equals N minus 1. Add 1, 14 equals N. So we have solved for N. Alright, our next example is a bit harder than the last one, but it is still manageable. So our example says 3 means 35 and 45. What this means is that there are 3 numbers between 35 and 45 that we don't know, and we have to figure out what they are. So you could always solve this using guess and check, but there is a way to do this using the explicit formula. So we know that A1 equals 35, and we know that 45 is 1, 2, 3, 4, 5. 45 is the 5th term, so we know that AN equals 45 and N equals 5. So using all of this information, we can plug that into the explicit formula, and we can solve for D, and then add that to 35, this number, to get the answer. So 45 equals 35 plus 5 minus 1 times D. We're going to subtract 35 from both sides to simplify. So 10 equals 5 minus 1 times D. We're going to subtract 1 from 5 to get 4. So we're going to have, and then we're going to divide both sides by 4. So we're going to have 5 divided by 2 equals D. So our common difference is 2.5. So if we add that to 35, we get 37.5. We add that to 37.5, you get 40 and 42.5. 42.5 plus 2.5 is 45. So we have found our 3 means.